Okay. I would do this as you go with me. This is another one we wrote down in class. So we've got a glucose molecule. Okay, let's fix this. Why is this here? I do not know. Okay, that's bugging me. All right. Now, we have a glucose molecule, C6H12O6. We just need to know that there's 6 carbons because we're going to keep track of this. Okay. In order for glucose to go to pyruvate through the process of glycolysis, count the number of G words I say. This is glycolysis, glucose to pyruvate. That costs us 2 ATPs. We get 4. So the total that we make, we net 2 ATPs. I'm just keeping track of how many ATPs. This will be important later because sometimes we can only go through glycolysis and we can't do the rest when we don't have any oxygen, when we're going through anaerobic respiration. So just keep track that when we go through glycolysis, it takes 10 enzymes, 10 chemical reactions, takes place in the cytoplasm. We make 2 ATPs, and we also make 2 electron carriers. We're not going to distinguish NADH, FAD. We're not, just trust me, 2 carriers of electrons. This is going to carry some electrons down into the electron transport chain because that's what's making our turbine, and that turbine is going to spin and make all of our ATPs. So we're sending 2 electrons down. We make 2 ATPs, 2 electrons. Awesome. Also, we broke this glucose down into 2 pyruvates. Each one of those pyruvates has 3 carbons. Okay? So I will just remind you of that. 2 pyruvates. There's a little modification step. Okay? Pyruvate cannot enter the citric acid cycle. It has to be acetyl-CoA. Okay? It's like not tall enough or not cool enough, whatever. Just, it can't. So we have this modification of pyruvate into acetyl-CoA, and that happens in the mitochondria. So we have entered the mitochondria, and the citric acid cycle is like, no, I'm sorry, pyruvate. I need you to be acetyl-CoA. Fine. So we have 2 acetyl-CoA molecules now that gives off CO2, and we make 2 more cars. 2 more electron cars, carriers. I like to say carriers. 2 carriers. 2 more things that will carry electrons to our electron transport chain. So now we have 4 carriers. And we are acetyl-CoA, which is what we need to enter the citric acid cycle. We enter the citric acid cycle. We give off some more CO2. There are 8 enzymes, which means 8 chemical reactions. We make 2 more ATPs. So far, let's keep track. We have made a whopping 4 ATPs. That's not a lot of ATPs. Okay, 4 ATPs. But what we have made, 8 more carriers. So let's count them up. 8, 9, 10, 11, 12. We have made 12 electron carriers for the electron transport chain. This is going to be important. Wait for it. Build the suspense. Also, I'm making one of these charts to keep track. So in our electron carriers that we made 2 in glycolysis, we made 2 in pyruvate to acetyl-CoA, and we made 8 in the citric acid cycle. Okay? ATP, we made 2 in glycolysis, and we made 2 in the citric acid cycle. In glycolysis, we gave off 2 CO2s. In the citric acid cycle, we gave off 4 CO2s, and we haven't really made water yet. That's going to happen in the electron transport chain. Okay? So, glycolysis. Glucose to pyruvate. A bunch of things happen, okay? I'm going to show you some chemical reactions, and you're not going to panic. Your eyes are not even going to twitch. It's fine. Okay, here's glycolysis. This is your life when you take biochem. It's going to be super fun. You're going to be able to do this. It's going to be delightful. You're going to enjoy the entire thing. Glucose is phosphorylated. You're adding some phosphorus there. Where's that phosphorus coming from, by the way? You went from a triphosphate to a diphosphate. You borrowed one of those phosphorus. You're like, I need one of those. So you got ATP and a little bit of energy. And look, there's your phosphorus. Okay? And yeah, and you use it, here's the whole thing. An ATP goes in here, an ATP goes in here. Look at that. You get phosphorus here. See, we're actually using that phosphorus. And we're going through some more chemical reactions. We're going through some more chemical reactions. And then eventually we get a pyruvate. Okay, and what happens here? We add the phosphorus. And then what do we do here? We get the phosphorus back in ATP. Crazy. Here is, there's a video. I will put these slides on if you would like to watch the video. So we are going here from pyruvate to acetyl-CoA, and we're giving off CO2. Okay, remember, we are entering, pyruvate enters the mitochondria, but it can't enter the citric acid cycle, so we have to make it acetyl-CoA. And from that process, we make some electron carriers. Yay, electron carriers. Okay, we are officially acetyl-CoA. See us there as acetyl-CoA? Yeah! We are getting on the ride, the citric acid cycle ride. All this magic happens. Look at all that fun, right? And who cares? We're just keeping track of things that are going on. We are oxidizing 3 NADH, 1 FADH. Again, doesn't matter. 4 electron carriers. I don't need you to know the NADH and the FAD differently. Just know that 4, this says 1. I said 8 and 2. For every glucose molecule, we get to ride twice. We get 2 tickets for the ride. Remember, because glucose made 2 pyruvate, which makes 2 acetyl-CoA. This is why I told you to keep track of the carbons. Because a glucose molecule gets to ride the citric acid cycle twice. It's, remember we talked about it in class, like sometimes you're on the ride at the fair or whatever, and there's nobody else in line, so the carney's like, you want to go again? You get to ride it twice. So you make 2 ATP, and you make 4 electron carriers. Okay? Here's our total outputs. 4 ATPs, 6 CO2s, and 12. There's just a whole lot of electron carriers going on here. Okay? So now, we have done this entire thing, this whole business of glucose, to get to the point where we are going to make a turbine that will create ATP, like a generator. Okay? So, let's look at it. This is the electron transport chain. This is the precursor. We used all of these electron carriers to shove these hydrogen ions up here. Okay? Active transport is when I'm actively shoving you in a closet. It costs me energy. It costs us all these electron carriers that we have done to shove these hydrogens up into the membrane space. I know you're saying, I could not possibly care about this. Trust me, the magic is coming. Stay with me. The magic is coming. Okay, here's the magic. This is our turbine. Okay, this is the turbine. Here's the big picture. Okay, stay with me. We created all of these cars. I'm calling them cars. NADH, FADH2, these carriers. They're carrying on the whatever. They're carrying all these to this inner matrix of your mitochondria. Why? Why do they do this? I'll tell you. They do this to take these hydrogen ions. See these electrons? They shove these hydrogen ions up here. See all these hydrogen ions? They're up here against their concentration gradient. They don't want to be there. They're introverted. They don't want to be around this many other hydrogen ions. Absolutely not. They hate it. They hate it. They hate it. We keep shoving them up here. This electron goes down, shoves another one up. It goes down, shoves another one up. And then they finally are like, oh, thank God, I can get out of here, right? This is you guys leaving the closet. But when they go down this turbine, just like a dam, they go down this turbine, they spin the turbine, and it makes ATP. What? Yes, 36 ATPs. We did this whole thing, this whole concentration grid, electron carrier, glycolysis business for this moment. when these hydrogen ions spin the generator and make this ATP. What? Okay. Now, we do have to back up and talk about something. So these electrons, boop, 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 okay? This has to leave, right? It's like traffic. It has to exit so other ones can come and move the hydrogen ion. If it doesn't exit, it backs the whole system up. And we'll talk about that in a bit. How does it exit? What is it? It's just sitting there waiting. What is it waiting for? Oxygen. It's waiting for oxygen. This is why you need to breathe. You're like, what do I need oxygen for? I don't actually know. I know that I need it. You need oxygen because it is the electron acceptor. It accepts this electron, makes some water, and then this guy can leave so we can continue the cycle so you can make ATP. That is why you breathe. You breathe in oxygen because you need it here to be the electron acceptor. That's crazy. You know that's going to be on the test. You know I'm going to ask you that. Here's another version in case you didn't like my other one. Whoops. Okay, here's our electron carriers, moving our hydrogen atoms. Our hydrogen ions here are coming down the generator, making ATP. Here's our electron acceptor, our friend oxygen, right? And that's keeping the whole thing going. Here's, if we zoom way out, glycolysis into the mitochondria where it becomes acetyl-CoA. Acetyl-CoA gets 2 tickets to the citric acid cycle. All of that is just to make these electron carriers. Those go into the electron transport chain to move those hydrogen ions to make our generator. Okay? Total business here is ATP, right? 30 to 36, depending on efficiency, cellular respiration, all that good stuff. These videos will be online. Now, what happens when this whole thing gets backed up? Right? I said it could back it up. And it doesn't just back up the whole thing. Okay? So let's go to this picture. This gets backed up, but these guys are full. Their hands are full, the cars are full, whatever it is that you think of these as, they're full. So they can't run these processes. So the whole thing is backed up. So none of these ATPs get made, none of these ATPs get made. We are only doing this, friends, and this is only 2 ATPs. So you're going to get tired real fast. You drew this picture before. Oh, I cut it off a little bit. Sorry. This is glycolysis. This is a glucose molecule. Goes to pyruvate, right? This is our picture from last time, except we have backed up traffic. This can't work because we don't have any oxygen to accept those electrons. So these are full. Come up here, these are full. The only thing we have is pyruvate. And if it's you, you're going to start making, the pyruvate is going to be converted to lactic acid. Okay? Lactic acid, which is supposedly what makes your muscles sore, but there's some thoughts on that. I don't know. Maybe there's an exercise science person that wants to enlighten us on lactic acid. This is also how fermentation happens. Okay? Do you see, can you visualize what's happening here? The traffic is getting backed up because we don't have oxygen to accept those electrons. And the traffic is ridiculous. It's like rush hour. It's like no one can go anywhere. It's total gridlock. Here's the fermentation process, right? Lactic acid fermentation. We are just doing this glycolysis to pyruvate and to lactate over and over and over again because we can't do anything else. That is a bummer, friends. That is a bummer. And that is lactic acid fermentation. Okay, and that is carbohydrates.